All right, welcome back. Today we are going to start looking at some more reasoning, and we are going to start looking at proofs. And what proofs basically are is a way to show what you know and how you know it. You can't just say, I know this just because, or anything like that. So what these are going to do is work on having a statement and a reason, a property, a definition, something like that that you can actually use to prove why you can say what you're going to say. But before we start doing that, when we start with algebraic proofs, it's important for us to understand like why we can do the things in algebra that we can do. So it's things that you do automatically when you're solving equations and you don't really think about why you can do it. But the good thing about math is there's a reason or a theorem or a property or something that always says why you can do something. So when we start looking at some very, very basic equations. X plus 5 equals 9. Okay, well, we know, what do we do when we go to solve that? We subtract 5 from both sides, and we get x equals 4. Okay, well, the reason that we can do that, and keep the balance of the equation is we do the same thing to both sides, and we are subtracting the same thing from both sides. So when we subtract and it remains equal, that means that we have the subtraction property of equality. That is what that's called. That's why we can do that. And I'm just going to abbreviate it to the subtraction property, but it's technically subtraction property of equality. So then if we look at the second one, x minus 8 equals 12. Well, what do we do to actually solve that? We add 8 to both sides, and we get that x equals 20. Okay, well, what's the reason we can do that? Why can we add the same thing to both sides and have it remain equal? It's called the addition property of equality. Okay, same basic idea here. We're just going to keep moving through the basic things here. So if we have 4x equals 20, we always say, well, 4 times x equals 20. To undo that, if we want to get x by itself, as long as we do the same thing to both sides, it remains equal. So in this case, to undo multiplication, we divide both sides by 4. And why can we do that? You guessed it, we use division, so it's called the division property of equality. All right, last one. I think you know where we're going with this one. If we have x divided by 2 equals 3, when we go to solve that, to undo dividing by 2, we multiply by 2 on both sides. And we get, those cancel, and we get x equals 6. Well, what did we do to both sides of the equation to keep it equal? We multiplied. Hence, it's called the multiplication property of equality. And these are some of the basic properties that we're going to be using today when we're making these algebraic proofs. So let's see what that's going to look like. Okay, so here's the properties that we basically talked about on that last slide. We talked about the addition property of equality, which basically means you can add the same thing to both sides. We talked about the subtraction property of equality. You can subtract the same thing from both sides. The multiplication property of equality. You can multiply both sides of the equation by the same thing. The division property of equality, you can divide both sides by the same thing. And last, the substitution property of equality, which we use quite a bit, like if you think back to our last chapter test or some of the things we've done previously, when we get an answer like x equals 5, we can always go back and substitute it back in anywhere that there's an x. So that's basically what the substitution property is. Okay, some other common properties that we will use, not so much with the algebraic ones, but they'll come along even more so here when we start talking about geometric proofs. The reflexive property, basically, it's a little common sense. Anything is equal to itself. A number can equal itself, a segment can equal itself, and an angle can equal itself. The symmetric property, so a lot of times when you solve an algebraic equation, you might end up at the end saying, 5 equals x. Okay, well, we know that that also means that x equals 5. Why is that true? Well, it's called the symmetric property of equality, where we can switch the order. Okay, so if we end up with 5 equals x and we wanted to show that x equals 5, we could just switch the order and call it the symmetric property. And then the transitive property, we will again talk about way more as we move forward in this chapter and in the next chapter, but it's a lot like the substitution property, where basically if A equals B and B equals C, you can substitute C in there and you can get A equals C. But we'll kind of get along with that just a little bit more a little bit later. And then one more property. So we have the distributive property. Again, it's one that you know, it's one that you use. Basically, the distributive property says if we have this equation like this, what's the first thing that we do? We distribute. And then, so we would have 2x plus 10 equals 16. And the reason we can do that is the distributive property. So these are all properties we need to keep in mind here today, and then in our next class when we do a little bit more with algebraic proofs, all of these properties are just going to keep coming back that you'll have to use. Okay, so here's what a 2-column algebraic proof looks like. If you notice, there are 2 columns. We have the left column over here, and we have the right column over here. The column on the left is what we are saying is true. The column on the right is why we can say it's true. So over here on the right is where we would put those properties: the addition property, the subtraction property, the distributive property. All of those properties that we just talked about in the last couple of slides, those go over here. The results of our equations, like what we get each time, go on the other side. So let's see what that'll look like. Let's start with a very basic, probably 2-step equation here. Okay, you can probably write out, if you want to actually solve it off to the side or something first, just to make sure you know what your answer is going to be, you can do that. But the very first thing that we do every single time that we write a proof, this right here is the information that is given to us. That is what they tell us that we have to solve, the problem that we need to solve, and we always rewrite it exactly the same in the first step of our proof. So the very first thing that we do is we just rewrite 6x minus 11 equals negative 35. Okay, now the reason that we can do that, okay, this is going to be the same reason that you use for the very first step of pretty much every single proof that we do from here on out. If they tell you that that's what you're given, the reason is given. And when you go to do these on tests and homework and things like that, you can get points just for writing down the given information. So never ever leave anything blank. Always make sure you put as much information in there as you can. So the first thing that we are going to do to solve this equation, well, what would we do? We would add 11 to both sides. So we don't actually show all this, so I'm going to add 11 here. And we end up at, our next step is 6x equals negative 24. Okay, so what did we do to get from the first green step to the second green step? We added 11. What's that called in our properties? That's called the addition property of equality. Okay, then in red I'm going to do like what we're mentally doing in our head, or kind of the work that we would be showing. The next thing that we do is we divide both sides by 6, and we get that x equals negative 4. And how did we go from this green step to this green step? We divided by 6, which is just the division property of equality. And once we get it solved, where we have x equals negative 4, we're done. And I always like to go dot, 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 done. Okay, so this one just has a couple more steps. Step 1, always write down the equation exactly the same as it is. And the reason we do that is that's what's given to us. That's our starting point. So the very first thing, I'm going to write it exactly the same. 3x plus 2 equals 23 minus 4x. And again, anytime we rewrite the exact same thing in our algebraic equation, that was the information that was given to us. That was just here, and we brought it down. So now I'm going to do it in red again here. What's the first thing that I would do to solve this equation? Well, I want all of my x's on one side, so I would add 4x to both sides. And I would get 7x plus 2 equals 23. And what did I do to get from this green step to this green step? I added 4x to both sides. So that would be the addition property. So the work that you show in between here, like this, doesn't actually have a reason that goes along with it. That's not a row of your proof. Only the one equation to the next equation is actually what you're going to put with reasons next to it. Okay? So then, now we have 7x plus 2 equals 23. My next step that I would do is I would subtract 2 from both sides. Okay? And I would get 7, oops, trying to stick with my colors here. And I would get 7x equals 21. To go from this green step to this green step, what did I do? I subtracted. So I'm going to have the subtraction property of equality. Okay, and then in my last step, I'm just dividing by 7 on both sides, and I get x equals, oops, same thing. I get x equals 3. And how did I go from this green step to this green step? I divided by 7, which is division property. Okay, so once I get down here to where I have the equation solved, I can be dun, done. Okay, so why don't you pause the video? I want you to try to work through this. Okay, take a couple minutes, see what you can come up with, and then keep in mind that when we solve equations and we move variables from one side to the other, some of our work might look slightly different, but our reasoning should still be there. So pause the video and see if you can do this one on your own. Okay, so I have this written out here, so I'm just going to talk about it a little bit here just to see how you did. And if you notice, okay, some of you on this very first step right here, some of you might have added 2p to both sides, in which case you'd have the addition property, and some of your work is going to look different. Everything's going to be kind of, the signs will be opposite and things like that, but that's fine as long as you end up getting with the correct reasoning, get down to the correct answer. So as I went through, I subtracted 10p from both sides, and then I added my 9 over to both sides, and at this point, with my division property, I got p equals -8 over -12. Okay, so that's just one step, is to get that fraction, -8 over -12. And that's the division property. But then if we simplify it, okay, negative divided by a negative is a positive, and we get 8 divided by 12, we get 2/3. We don't want to put a decimal. We're never going to put decimals in here. That's just, the reason for that is just called simplify fraction, something like that. Sometimes we will combine like terms. So sometimes there's cases where you'll have the same variable on the same side, and you might have to combine like terms. So there's another property that we have other than simplify. Another one that comes up quite a bit is if you have to combine like terms. We didn't have to do it in this one, but there are instances where you would have to. So just keep that in mind. Okay, so now here we have 2 problems I would like for you to try. Okay, so there are 2, and so you want to start out with your t-table just like that, and you have your statement on the left, your reasons on the reason or property on the right. That's kind of where we start with our proofs every time we start one on our own. So you have your statements on the left, your reasons or your properties on the right, so you should make a t-table for both of them. See what you can come up with, try them on your own, and then you can check back with me. Okay, so hopefully you've had a minute to try these, and I have them both solved out here for you if you want to look at them. You might notice I did not show all of my different colored steps in there. So like for instance on this first one, to go from this step to this step, I added 5z to both sides. I didn't write that in there, but I added 5z to both sides, so I called that the addition property. And then kind of the same thing all the way down. The one thing that we hadn't really done before is the way that I solved it. I ended up with z on the right. I like to prove with z on the left, so I wanted z equals 4. So when I switched the order of those, that, remember, was called the symmetric property of equality. So if you ever end up with the z on the right instead of the left, you can always do that. Oops. And then over here on the right, we just use the distributive property, added to both sides, divided on both sides, and got our answer. So hopefully you were successful with that. If not, feel free to ask any questions that you might have. And there is a homework assignment in Schoology that's algebraic proofs. So that will be you'll have a link in Schoology with the assignment with the worksheet in it that you'll have to then go ahead and submit again. So good luck.